All right, welcome back, class, to our second lesson, which we are going to be talking about the Vespri theory using the molecular compound of phosphorus bromine 3. So for today, we're going to talk about the model of it, the structure of it, and how to calculate the EN for it and all the sides like that. So first of all, we're going to make the structure for it. So we're going to just put, because there's only one phosphorus, we'll put it right in the middle, P, like that. And since it's only got 5 electrons, we don't need to add anything else because we got to connect the bromines to them. So since it is a trigonoplanar figure, it's going to look like this. It's going to have lines, and those lines mean that there's 2 electrons connected to those, and it's connecting the elements together. So I'll put the bromine on the side over here, Br, Br, and Br. So we're going to put 1, 2, 4, 5. And 1, 2, 3, 4, 5. We're gonna put 5 around all the bromines because they have 7 outer electrons, and that line already equals 2, so we'll put it like that. So the structure should look like that, connecting the phosphorus with the bromine, because it'll have 6 electrons around the phosphorus, and then it should have 7 7 around the bromine. So to calculate the EN, we have to know the electronegativity of each thing. So for phosphorus, here, 1 times 2. So phosphorus, it will have, what is it? I wrote it down over here, 2.19 and 2.96 for bromine. And so for bromine, since it is the stronger element, when we talk about, it'll get us 0.77 for the EN. So it should look like that. Sorry, the math should look like that. You minus them, and that's what should get you the EN, which is right there. I wrote it down fully right there. So yeah, your structure, let's talk about the scans, sorry. Your structure should look like that because it is a trigonoplanar, because it has no other electrons and 3 X's around it and 1 A. So since it is a 0.77, that does make it a polar bond, which is pretty much saying that they do connect together and they do share, but the electrons are going to be more lenient to one side, which would, whichever has the higher negativity, which is bromine in this case. So the electrons in this case, instead of being on a line like that, they would more likely be on the side of bromine for each of them. But they do share it still. And yeah, that is your lesson today.